This is going to be a short tutorial about how to use the Mission Control app in Monty's Python shell. Now this app may be embedded in a lesson or it could be assigned directly to you as a web page. The mission that you will be attempting to finish should be built into the web page itself. So let's talk about the two different states that the system can be in. You could either be in the sandbox mode, which I'm in right here, and you can see in this box right here it says sandbox. Sandbox just allows you to, it's free play. You can manipulate the state of the system by entering code, and it doesn't have anything to do with the lesson. You use the sandbox to learn about the app, how it works, and to practice. When you're ready to start the mission, you will select your mission here. In this case, the junior astronaut is the mission that is assigned with this particular instance. Let's just stay in sandbox mode for now, and I'll show you how this works. Real quick, let's just do an overview of what's on the screen. So at the top, this panel here gives us information about the app. It will show the name of the mission that we're running, what mode we're in, if we're in a mission mode or sandbox mode. And if we're in a mission mode, it will also show you the number of each of the tasks that are in the mission and whether or not we've accomplished them correctly or not. I'll show you that in a minute. This button right here is a bitmap. This shows you the bit position of all of the different systems in the rocket ship that you can control. Over here is a translation of the current state of the system. The state of the system is basically a number. At any given time, there's a number that describes the state of the system. And the state determines which of the systems, subsystems, are on or off. And there are 5 different systems on the ship: engines, thrusters, stabilizers, diagnostics, and life support. And each one of those has 4 subsystems labeled 1 through 4. So if you look at the bitmap, for example, you can see that stabilizer subsystem 3 is at bit 10. There's a button right here at the top that will put the screen into full screen, which might make it easier to play the game depending on what else you have up on your screen. Now, when the systems turn on, these switches will switch to the up position and they'll turn green. So that's how you know if a particular system is on or off. This row you've already seen. This is where you load your mission. These are programmable function buttons. There are 5 of them. To program a button, you click the gear and then it brings up a code editor and you enter the code to program that button here. I'll show you that in just a moment. The enter param box, this is the argument that will get passed for the function. And to call the function for this button, you just click the button itself. This box here is our terminal code editor, and you can control the state of the system from this terminal in sandbox mode and some of the mission modes. Sometimes it will require that you program a button and the terminal may be deactivated. But in sandbox mode, the terminal is activated. This is your command rail. This is how you execute code right here that's in the terminal. You can reset the state of the system to the prior task. You can pass on a task, and you can jump around from one task to the other right here. This box over here is our CRT screen. This is how the instructions are coming to us on what systems to manipulate. So this will populate with different information when you're in the actual mission. Okay, so let's go through and let me show you how the allsys works and how to manipulate the state of the system. So there's 2 important words you need to remember: allsys and engage. Allsys is a global variable that sets the state of the system. With every system off, allsys would be set at 0. So if I were to print the value of allsys right here, you can see in my terminal output that it is 0. Now I can change the value of allsys to something else. Let's change it to 17 and execute. So you can see now the value of allsys is 17. But you notice up here in my panel up top, the state of the system has not been changed. It still shows 0. And the reason for that is that you have to engage allsys in order for the change to take place. That allows you to have multiple lines of code manipulating allsys from one to the other before you actually engage the final answer. So to do that, we would do engage allsys like that. So we're going to call, there's a built-in function called engage, and we'll pass allsys as the argument. So now when I hit the execute button, whatever the state that relates to the number 17 is will occur in our systems. And we can figure out what that is. 17 is 1 more than 16, and we know that 16 is the value here at the 5th bit of our system, which would be diagnostic subsystem 4. So when we hit this, 17. So it's going to turn on this one, 16, and there's one left over, so that should also be life support system 4. So 17 should relate to turning on diagnostic 4 and life support 4. Let's try it and see. Okay, there it goes. So I click the execute button. You can see that the state of the system changed to 17. And you can see here, diagnostics 4 and life support 4. That is the state that relates to the number 17. And you can see up in our box here that it shows you 4 different representations of the state. It shows you decimal, hex, octal, and binary. Now you can set all sys to any of these values using integer literals in any of those number formats. For example, let's change the state of the system. Let's put in a binary number. Let's turn on stabilizers 1 and 4 and leave everything else off. What would the value of all sys be as a binary number? Well, 0b, because it's a binary literal. And then let's do the stabilizer grouping of 4 bits first. So I said 1 and 4, so that would be 1, 0, 0, 4. Where that first one, that's our stabilizer 1 subsystem. And then goes 2, 3, 4. And then everything else off, we need 8 more zeros. So 4 zeros for the diagnostics, 4 zeros for life support. So you can see that this number right here will correspond to stabilizer 1 and stabilizer 4 being on and everything else being off. There you go. So I clicked execute and you can see that's exactly what happened. Now you don't have to set the value of all sys directly. You can also manipulate the value of all sys from its current state. For example, so all sys is currently set at 2,304. I can see that up in this box here. I can use different operators to manipulate the value of all sys. For example, I could just add 1 to it. Let's say all sys plus equals 1. So that will just manipulate the current value of all sys by adding 1 to it, which should turn on life support system 4. There you go. Okay, let's take a look at how to use a function button. So I'm going to program function button 1 right here. So to program the button, you click on the little gear icon, and that opens a little code editor that you can write the code in. So I'm going to define this function, and the function name has to be the name of the button. In this case, F1, and we do it lowercase. And then the function will have one parameter, mask, and we need to get the global value of all sys. So I need to declare global all sys, and we're going to manipulate that value. So let's say we want to program this button to turn bits on. So the bitwise operator that would be good at turning bits on would be the OR operator. So I'm going to say all sys OR equals mask. So we're going to apply the mask to the value of all sys using the OR operator. And then the last thing we need to do is we need to engage all sys after we've changed its value. Okay, so I've got the board reset back to 0. So let's say we wanted to turn on thruster 3 right here. So what would be the value of thruster 3? Well, we could enter that as a couple ways. Let's do it this way. Let's do a 1, and then let's just do a left shift. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's just shift it over 13 times and run that. And there you go. We turned on thruster 3. Pretty handy. All right, so hopefully you guys enjoy the Mission Control app. It's a great way to learn your different number bases, to practice converting from a number in one base to a different base, and practice using your bitwise operators.